So what we're showing in our booth right here is Rapids. And Rapids is I would say, our next generation killer app for GPUs. With GPU computing, NVIDIA started out in the scientific and technical computing space. A few years after that, we established a leadership position in artificial intelligence computing and deep learning. And what we're talking about here today is brand new. It's called Rapids. And Rapids is all about accelerated machine learning on GPUs. When we talk about deep learning, we often say that deep learning is a category of an algorithm within machine learning. So in some sense, machine learning and deep learning are related. The idea behind machine learning is that we want to use data to answer questions, like make predictions, categorize things, and learn from the data, learn important insights from the data. And so, of course, those statements apply to deep learning. They also apply to machine learning. Machine learning is a much broader scale of algorithms that goes back, at least in terms of commercial use, over a longer period of time. So it's a much bigger space than the deep learning space is today. There's lots of companies that are using machine learning for their enterprise applications. You look at the chart that we're showing in the lower right-hand corner on the display. What we're talking about there is an end-to-end machine learning workflow. The software stack that we're introducing sits on our accelerated computing platform, that's CUDA at the bottom. And what we're introducing is a set of libraries that are usable by machine learning scientists like cuDF to do your data wrangling and your data import and data organization, and cuML, which is a library to accelerate machine learning training directly. And then on the third library that we're depicting there is cuGraph, which is a library which is going to facilitate graph visualization and graph analytics in a machine learning workflow. So those three libraries constitute the core of Rapids. Rapids is a set of libraries that exist in a C++ or a Python environment. We have Python interfaces, which is the most common language used in machine learning. And using the Python interface, you can write Python scripts, which is what we're depicting there on the screen, to do machine learning, data organization, data wrangling, machine learning training. We have some machine learning algorithms, very advanced machine learning algorithms like XGBoost, which is one of our leading algorithms that we're introducing. And we're seeing speed ups from an end-to-end standpoint, an overall workflow standpoint. We're seeing speed ups in the 10 to 50x range. And so when you demonstrate that level of a speed up to a machine learning data scientist, their jaw hits the floor, but at the same time they immediately imagine the possibilities, what this means for improved accuracy and reduction in cycle time. If you're a machine learning data scientist and you have a very, very time-consuming workflow, it limits the amount of things that you can explore and try. And so by reducing the time to solution, or by reducing the turnaround time in their workflow, it allows them to explore a lot more variables and possibilities in the machine learning space to improve the accuracy of the problem they're trying to solve. www.rapids.ai is our open source portal for this. And NVIDIA also has landing pages where we talk about Rapids. And if you're a machine learning data scientist and you want to get going, you can install this using Anaconda, using NVIDIA GPU Cloud, which is our container repository, so we have containers set up for this. You can also install it from Python directly using pip, and it's available on GitHub since it's an open source project.
Wonderful, thank you very much.